Well, thank you all for having me today. Can everybody hear okay? All right. My name is Daryn Lewellyn, and I want to talk about electrical safety today, and I want to talk about it from a practical standpoint, because that's the kind of guy I am. I'm not an engineer or anything like that. I'm not much on theory, so we'll talk about it from my experience and what have you. For those of you out there in the industry, been in the industry a while, have you noticed in the last 25 years, last 20 years, the last 15, last 10 years, electrical safety is changing? There's a lot more talk about it than there used to be. You know, I used to be a maintenance man in factories. I worked lots of different places. My first job, my first real job outside of my dad's machine shop was in Terre Haute, Indiana, a place called Terre Haute Malleable and Manufacturing Company in 1984, February 1984. And I'll never forget, first day on the job, my boss says, kid, you got to work with Bill for 2 weeks. Bill's our top electrical guy, and I was an electrical guy. He had a brand new degree from Ivy Tech, and I was the smartest guy on the planet. And you work with Bill for 2 weeks, and if you're still alive after 2 weeks, we'll make you an electrician. That was kind of the safety culture. So I listened to everything Bill said. One day, me and Bill are out on the plant floor. Now, it's a dirt floor. You know, if you ever, it was a foundry. They made castings, and so the floor is made out of volcanic ash, bentonite sand, and coal dust mixed together, and hydraulic fluid. The hydraulic fluid, all the machines leak, but it kind of held the floor together. It was kind of nice. And one day, me and Bill are standing on this floor in front of a 600 amp disconnect, and it's really old. And the older they are, the bigger they are. And it's a great big old thing. And a disconnect, for those of you who don't know, is just a big switch. Just that big knife switch. You know, it says on or off. And Bill said the following. He said, kid, when you turn one of these on or off, don't stand in front of it. Stand off to the side. Turn your head. Use your left hand and duck. I said, why? Well, sometimes these things blow up. What? That was new to me. Is it too late for me to be a carpenter or something? What do you mean they blow up? How much they blow up? You never know. He said, how much? Anybody else have that same class? You know, that was a good class. That's still good information. If you're going in to do electrical work right now, that's still good information to do. Everything Bill taught me was absolutely correct. Problem was, in 1984, that was the total class. That was it, wasn't it? That was everything. That was all we knew. Turn your head and duck and don't stand in front of it. That was it. Well, today we know a lot more. Today we know a lot more. You know, me and Bill are out there wearing polyester disco shirts, you know, doing this work and looking good, I'm sure. And, you know, but that was all we knew. You know, that was 26 years ago or whatever that was. And, you know, the very first electrical safety class I was ever in, I was the instructor. I never once in my life was given an electrical safety class by an employer. And I worked for 10 years in electricity, you know, in maintenance doing electrical work. Never once got one. Today that's kind of unheard of. Today we do electrical safety training. It's a hot topic. My point is, lots of things have changed since 1984. So look around your facility. If, you know, electricians are still wearing polyester disco shirts, it might be, well, bad fashion sense for one, but, you know, maybe a safety issue there. Maybe a safety issue. Well, let's get started with this stuff. So there's been a huge change in electrical safety over the last several years. We're going to talk about today about 70E. In my opinion, everyone needs to implement 70E. Don't do it for compliance. Do it to prevent injuries. Don't do it because you think OSHA requires it. Don't do it to avoid a citation. Don't do it because corporate safety said you had to. Do it to prevent injuries because it does and it will and it can. It does it all the time. Okay? Me and Bill in '84 didn't know any of this stuff. But now we know more than we did. A lot of people, a lot smarter than me, have developed these things and have a way to protect. It's not the law. And it doesn't matter. It doesn't matter if it's the law or not. Sometimes we come up against people, we meet folks that say things like, well, we're not doing it because it's not the law. Don't waste a second of your time at work arguing about or worrying about whether it's the law. Do you know who doesn't care if it's the law or not? OSHA. OSHA doesn't care if it's the law or not. They will still write you citations. But don't do this to avoid a citation. Do it to avoid the injury. An injury caused from an arc flash or electrical shock, the injuries make the citation look ridiculous. You know, an injury can cost hundreds and hundreds of thousands of dollars. There were two guys that were burned in Rotterdam, New York, maybe about 3 years ago now. And one of them had to be lifelined in a helicopter to the hospital. Do you know that the helicopter cost more than the OSHA citation? The OSHA citation was like $14,000. And the helicopter ride cost more than that to the hospital. So don't do this to avoid an OSHA citation. That doesn't make any sense. Don't worry about if it's the law or not, because that just really doesn't matter. Do it because there's an easy way to prevent these injuries. And that's what we need to be doing. It's not that difficult. We got to work on some culture change issues and some other stuff. But this can get done. And we all can do it, and we all need to do it. In 1976, when we were all very small children, at OSHA's request, the National Fire Protection Association created 70E. It's not the law. OSHA's not adopted it, but it's how to comply with what the law says. OSHA says you've got to, whoops, let me back up. OSHA says you have to protect people from electrical hazards. Doesn't tell you how. OSHA says you got to, provide PPE. Doesn't tell you how to provide that for electric shock. OSHA tells you got to do all these things, but doesn't tell you how. 70E is how to comply. 70E is how to comply with this. The number one thing that you can do to protect people from electrical hazards in your workplace is to turn it off. Have them not work energized. Okay? That's the number one protection. I say that, OSHA says that, NFPA says that. Don't work live. Work de-energized. Turn it off. I guarantee you, back in 1984, me and Bill worked everything live. You know, we replaced all kinds of things live. Bill, hold this wire, it's hot, while I do this. And then, we'd be like we were brain surgeon, replacing relays and not turning anything off. Remember one time a three-phase motor was running that didn't have a disconnect. And we couldn't turn off the other three motors that was fed from the same disconnect. And we cut the power off using our Klein linesman's pliers. You would never dream of doing that today. But in 1984 in Terre Haute, Indiana on Maple Avenue, that was pretty common practice. But you got to justify it now. If you're going to work on a live circuit, if you're going to expose yourself in a live circuit, you have to justify it. You have to justify it. Let's talk about what working on means. 70E defines working on as two different things. One is diagnostics. The other is repair. Diagnostics would include troubleshooting, voltage checks, visual inspections, that sort of stuff. Repair is any time you're modifying the circuit. If you're changing a fuse, if you're tightening a lug, you're changing a component, that's repair. Okay? That's repair. And we'll come back to this in a minute because justification plays into this. How do you justify doing live work? It's three ways. Okay? 70 gives you three ways. One is a greater hazard. If you work at a hospital, got a hospital person there, if you've got, an intensive care unit with 3 sick people and the maintenance person is down in the basement and has to work on the boiler control panel or the boiler circuit breaker panel, and you told them, well, we got to shut these off. We can't work them live. But if they shut the panel off, 3 people upstairs die because that panel also feeds life support equipment upstairs. That'd be a greater hazard, wouldn't it? Airport, if you work at the airport. If you work at the airport, you can't turn off the radar. You can't turn off the runway lights to work, especially if my plane's coming in, right? You got to work those things live. Or if it's infeasible. Now, what you think is infeasible and what OSHA thinks is infeasible likely are not the same thing. You just say, oh, man, it's really hard to turn off. I can't turn it off. Well, OSHA doesn't care. They think you can turn it off. They mention one examples like a continuous process, like at a chemical plant or something. But I can't tell you if your process meets their infeasible standard or not. But we'll come back to infeasible in just a second. Or if the circuit's under 50 volts and there are no other potential energy, things like an arc flash that might hurt you or something. Okay, so under 50 volts, greater hazard or infeasible. Let's say that you've been asked to fix a machine. You work at a factory that makes widgets, and someone says, hey, the number 6 widget machine's not working. And you're called out there to it, and you're wearing your FR clothing and all your equipment, you know, your Cintas uniform and everything is on, and you're protected, and you're trained to do the work. You are allowed to do troubleshooting and do it live. Okay? Because that's part of diagnostics work. Matter of fact, can anybody think of a time where OSHA requires you to do live electrical work? There's at some point where OSHA actually makes you do live electrical work.
Verification.
There you go. Verification of isolation during lockout, tagout is live electrical work. Some people say things like, we don't need 70E because we're just going to shut everything off. Well, guess what? You can't shut it off without doing live work. Lockout, tagout involves doing live work. It's diagnostics work, but when you go check that circuit to make sure it's off, you're doing live work. You know why? Because you haven't verified it's off yet. So the process of verifying it's off is considered live work. Matter of fact, 70E requires you check your meter first on a live circuit. That's live work. Then to turn off the circuit and verify that it's off. That's live work because you've not verified it's off yet. And then once you verify it off, you have to go retest your meter on another live circuit, and that's live work. So no one gets out of 70E by saying we have a no live work policy. There's no such thing. Now, I got a big pat on your back if you want to have that policy. I like doing no live work, but just remember, you got to do live work to not do live work. This doesn't have to make sense, okay? So you got to do live work to not do live work. Remember that. So it's infeasible.